Form 3 Revision Worksheet, End of Term 3.
Number 1.
1A. So we have a flagpole that's standing vertically on the ground. So we have a flagpole, and so we draw this line to represent our flagpole, and it's standing vertically on the ground, so vertical, from a point on the ground 10 meters away. So on the ground 10 meters away, so this would be 10 meters here. So this would be the point on the ground that's 10 meters away. From the foot of the flagpole, the angle of elevation, so if we imagine this is eye level, and we elevate and we look up, so the angle of elevation is 60 degrees. So they want us to find the height of the flagpole. So this is a right angle triangle, and we can use trigonometry. So we know that it's 10 meters because this is 60 degrees here. We know that this is hypotenuse opposite the 90 degrees. We know here then this would be adjacent. And we know that height then would be opposite. So sine, cosine, tan, SOHCAHTOA, or whichever method you use to remember it. We know we have an angle. So sine, cosine, tan, and we have adjacent, and we are looking for opposite. So therefore the one with all three ticks would be tan. So we are going to say that tan 60 degrees is equal to opposite, which is h, over adjacent, which is 10. And this becomes simple algebra now. So the 10, we want to get rid from the 10 on this side, so we'll multiply both sides by 10. We put those values, so we get 10 multiplied by tan 60 degrees is equal to h. We put those in the calculator, so we get that tan, we make sure our calculator is in degrees, and we get that tan 60 degrees is 1.732. So we get 10 multiplied by 1.732 for h. And so when we multiply that by 10, we get that h is equal to 17.3 meters. 1b. There was an error in this question, so please remember to fix the error, and that is they should have given you the angle, and this angle here should have been 60 degrees. Okay, so we want to find the distance BC. So if we look at this diagram, we see two right angle triangles. We see a small one and we see a large one, and we're going to use those two right angle triangles to help us solve this question. So the small one will be TCB, where this is 60 degrees, and the big one, and TC is 9 centimeters, and the big one is TCA, and this is 9 centimeters here. Okay, so the first one, we want to find the distance BC, so we'll be dealing with the small triangle. So if we look at the small triangle, we have an angle. We want to find BC, and BC would therefore be the adjacent. We know opposite the right angle is the hypotenuse, and we know that this here would be opposite. So using sine, cosine, tan, SOHCAHTOA, or any other method that you may wish to use, we look to see we have an angle, so we can use sine, cosine, or tan. We have opposite, and we are looking for adjacent. Therefore, we would use tan. So we will get that tan 60 degrees is equal to opposite, which is 9, over adjacent BC. And we need to figure out what BC is. If we put tan 60 in the calculator, making sure that our calculator is in degrees, we will get that tan 60 is 1.732 equal to 9 over BC. We multiply both sides by BC and we divide both sides by 1.732. So that BC would cancel and the 1.732 will cancel, and we will end up getting that BC is equal to 9 divided by 1.732. So 9, and we put that in the calculator, divided by 1.732 is equal to 5.2 centimeters. So we know that BC is 5.2 centimeters. So if we want now to get the distance AC, AC would be BC plus 20 centimeters. So CA is equal to 5.2 plus 20 centimeters, which will give us 25.2 centimeters. Now, if we want to get the distance TA, we're using the big triangle, and we know that this is 25.2. We know this is 9. We want to find the hypotenuse. So we can use Pythagoras theorem. And Pythagoras theorem tells us that TA squared, which is the hypotenuse squared, will be equal to 9 squared plus 25.2 squared. So 25.2 squared, we put that in the calculator, plus 9 squared in the calculator again. We will get, when we add that up, we will get 716. But that is TA squared. So we want to get what TA is. So we'll take the square root and we'll get that TA is 26.8 centimeters. So TA is 26.8 centimeters. And now we want to get angle TAC. So we use sine, cosine, tan again. So TOA. And we know we have opposite and adjacent. And we want to find the angle. So therefore we're going to use tan. So tan of the angle, tan of the angle TAC is equal to opposite over adjacent, so that's 9 over 25.2. So therefore TAC will be equal to tan inverse of 9 divided by 25.2. And we put that in the calculator and we will get, making sure our calculator is in degrees, making sure we put the 9 divided by 25.2 in brackets, and we will get that the angle is 19.7 degrees.